time, let's begin. Okay. First of all, we'll discuss the agenda, what we are going to learn today, or what we are going to go through this entire session. First of all, we'll cover the first section where we'll discuss introduction of ILE, what is ILE, and what is its purpose, and the modern programming features which are powered by ILE. Once we gather some understanding of ILE, then we'll jump to the next section down this session, which is ILE key concepts. I think most of us are already aware of the basic concepts of ILE. We'll go through them one by one, and we'll understand these concepts and how can we make use of these concepts in our day-to-day programming effectively. So basically, we have five key concepts: activation groups, subprocedures, modules, programs, and service programs. We'll go through these concepts sequentially in detail. And later on down the session, we'll jump to third section of this session, which is demonstration of examples on live IBMi server. So we'll log in into a IBMi server, and we'll see a few of the examples to understand whatever we have learned so far. And once the demonstration is done, then we'll move to the final section of this session, which is Q&A, where I will try to answer the queries if you may have any. Okay, so without any further delay, let's begin with the introduction of ILE. So what is ILE? I think as we all know, we all understand the full form of ILE. ILE stands for Integrated Language Environment. That means it supports multiple languages in a single system. Talking about a little bit of history of ILE, it was first introduced in 1993 with combination of C language as version 2.3. Later on, it was upgraded in 1994 when RPG, COBOL, and CL also joined the system, and the version named as 3.1, which is also commonly known as RPG-4. At this point of time, the previous model of programming was renamed as OPM, which we still know as Original Program Model. And the main feature of this version was any ILE language can call procedures written in any other language. And these procedures can be bound together to make a single program. Later on this session, we'll understand deeply what these two features mean. Talking about the evolution of ILE, as we understand, the initial version was known as OPM. Then one intermediate version was introduced, which was known as EPM. And later on, the modern version is known as ILE. So when ILE came into picture, EPM was decommissioned, and only two versions exist concurrently. One is OPM, and another one is ILE. So let's understand what OPM provides us. Inside OPM, we can have dynamic binding. That means we can call one program from other at runtime. And it used to have single entry point. And the data sharing limitation was there. Scope was very limited. And it used to support languages like BASIC, CL, Programming Language 1, COBOL, RPG. That's it. So when intermediate version was introduced, EPM, in this version, we introduced C language as well inside ILE. Sorry, inside the previous version of ILE. And also it got integrated with traditional languages, Pascal and Fortran as well. And finally, we had ILE into the picture and APM was decommissioned. There, apart from dynamic binding, we also got additional feature of static binding. Later on, we'll discuss static binding in detail. It is the very important feature of ILE. Apart from this, each procedure can have multiple I mean, each service program can have multiple entry points. Each procedure can be treated as an entry point, unlike OPM. And scoping the variables become quite flexible inside ILE. And it started supporting future language as well, uh, concurrently with traditional languages. So ILE came up with a lot of features. Now let's understand those features in detail. If we summarize those features, we can classify them in 8 categories. Number 1, binding. Number 2, modularity. Number 3, reusable components. Number 4, common runtime services. Then coexistence with existing applications, better control over resources, better control over language interactions, and better code optimization. Let's understand these features sequentially. Binding. Binding is the most common feature of ILE, as we all know. As the name suggests, what is binding? A module can be bound with the service program, or procedure can be bound with the service program, and then further it can be bound with the program. So binding became quite flexible in ILE, and the benefits it provided to the programmers was it helps reduce the overhead associated with call operations, and it speeds up the call. So prior to ILE, we only had dynamic binding, which was provided by OPM. But when ILE came into picture, we also got static binding as one of the flexible feature of binding. The main difference between this dynamic and static binding is when we use static binding, the two objects know each other well before they ever use each other. So before runtime, they know the definition of the procedure, they know the definition of the subroutines and everything. And static binding is much faster at runtime than dynamic binding, because they have the code written to the original program at the compile time itself. And static binding also is further classified into 2 categories, which we'll discuss in the later section of this session. Before that, we'll discuss the modularity. Modularity, as the name suggests, breaking down the program into smaller components. So what is the benefit of breaking down the components? The first and very important benefit is it will provide a faster compile time. The smaller the piece of code we compile, the faster the compiler can process it, which is obviously. And simplified maintenance. If we have small piece of codes, then it will be easy to maintain them. And simplified testing. And it also has the same reason. If we have the small code, we can test it in isolation. And we all know that if some routine or some procedure is tested in isolation, it becomes bulletproof and solid. And number 4, better use of programming resources. We can easily divide the work among the team if we have smaller components of the program. So why ILE emphasize on small routines or small procedures? Because it takes less time to understand. Number 2, it is easier to test, it is easy to debug, and it becomes bulletproof when it's quite small and it is tested successfully. And once it is bulletproof, it becomes a black box that we can use anywhere in our application, or maybe in another application as well. And if one routine is reused everywhere, there is only one place to find errors or make changes. So that is why I really emphasize on small routines or small procedures. That's why modularity is one of the important features of ILE. Now, reusable components. Since ILE promotes modularity inside modularity, we have learned that a program can be broken down into multiple small components. So those small components are prepared in a way so that they can be reused in multiple applications. For example, you prepare a small routine which fetches the current date. And there are multiple applications which want to use the current date. So that routine can be reused in all those applications wherever needed. So that is how reusable components become the most crucial feature of ILE, one of the most crucial features of ILE. Coming to the next one, common runtime services. As we all know that IBMi support multi-language environment. So if there's a code written in C++, and along with that, we have a code written in COBOL and RPG and SQL. All these codes can be compiled to module and can be bound together in a single executable program. And ILE provides common runtime services to all these codes. They provide the same debugger. You can use strdbg command to debug all these codes, or you can use the same subsystem to run these codes, same job queue and same out queue. So ILE provides common runtime services for different codes. Talking about the coexistence, uh, since it promotes multi-language environment, we can use the same picture to understand it. If any code is written in C++, written in COBOL, or it is written in RPG or SQL, all these codes can be combined together to deliver a single executable program. So all these codes written in different languages can coexist together in a single program or single application. So this flexibility is provided by ILE. And in the similar manner, we can have a better control of resources. If we have a single PF, that same PF can be reused in all these programming sources. C++ can also update the same PF, and same PF can be read or can be written or can be updated from RPG or from COBOL or from SQL. Later on, when we'll jump to our third section and we'll log into IBMi server, then we'll understand this better. We'll use multiple modules written in different languages they use, and we'll see how they use a single PF altogether. Better control over language interactions. So ILE provides a flexible environment so that all these programming languages can coexist and can achieve the same goal. Interaction between languages is made easier with the help of ILE. Let's take an example. An RPG program can call a C function directly, enhancing flexibility. So that's how we can control language interactions and better code optimization. So if we have a routine written in C++ or procedure written in C++, which is quite effective and commonly used in multiple applications. So even if the rest of the application is written in RPG, we can invoke that commonly used procedure and run it in our program. So that is how we can optimize our code in an effective manner. So after understanding the features, if we talk about the main purpose of ILE in a nutshell, it provides mainly two purposes. Number one, easy programming. The purpose of ILE is to provide tools to make it easier to call programs and procedures. And number two, it makes you more productive by making it easier for you to write reusable tools so that you never have to write the same routine twice. That's how you can optimize your productivity. Now, moving on to the second section of the session, where we'll learn key concepts of ILE. I know most of us are already aware of these key concepts. So I'm just going to give a one-liner description of these key concepts. And then when we'll jump to our demonstration section, then we'll understand these key concepts better. Activation groups, as we all know, it is used to share the resources effectively with common group of programs. And how can we clear the memory together for those programs? Sub-procedures are nothing but subroutines which can accept parameters and return some values. You can think of the sub-procedures like methods in Java or functions in C++. Modules. Sub-procedures grouped together into a single object. So these are modules. And module is not executable entity. Several modules combine together to create program, and program we can call through our command line and execute it. Now, service program, modules with many entry points that can be called from ILE programs is treated as service program. This we'll understand in our demonstration section. Talking about the problems associated with our ILE development and how can we solve it using activation groups. So let's understand the problem first. When an application consists of many different subprograms, each one has to be loaded into memory, number one. Number two, it can have all of its files opened, its variables initialized. Let's talk about a sample application. On my right-hand side of the screen, you can see there's a picture where you can see different boxes. Let's understand the first blue box as an application, which is known as order entry application. And it consists of several components like search previous order, fetch item information, get items price, discount calculation, append item to the order, text calculation, fetch customer information. And if we notice that search previous order also further broken down into two more components, fetch order header and fetch order detail. So talking about the problem here, what is the possible problem? To save time on the subsequent calls to each program, you would leave INLR turned off. This means the files for all the programs will stay open. Record logs can get left behind by mistake. Variables may remain in their previous state, and an override will affect all programs. That can happen by mistake if we use override. And for unloading the programs, what can be the possible problem we can have? We have to call each program with a parameter so that we can tell the program when you have to free up the space or when you have to turn on the INLR. Or you can use a reclaim resource command at once so that it can, but later it can close more than what we intend. And third option, which is obviously not feasible, that we leave everything in the memory until job ends. So none of these options seem feasible for development. If we talk about the solution of these problems, let's understand activation groups. Activation groups are like garbage bags. So when you want to take out the trash, what do? You put all the garbage into the trash, and then you empty the trash outside. So similarly, what we have to do, we have to load our programs into different activation groups. And when we are done with those set of programs or those group of programs, then we can clear up the space of that activation group. For example, here in this application, we are using two different activation groups. One is order entry, ORDENT, and another activation group, which is using a common group of programs for searching. We are putting these programs into activation group ORD search. So whenever we want to clear the space for search previous order, we just need to reclaim the activation group or ORD search. Or when we want to free up the space of, when I talk about the freeing up the space, it means we are freeing up the resources. Like we are resetting the variables, we are removing the record logs, etc. So in this case, for order entry, we can use the activation group ORDENT, and to empty this activation group, we can use reclaim activation group command and mention activation group name in this parameter. So this is how we do it. When we log in into our IBMi server, we'll see this happening live. And also, along with activation group, there's a very important and beautiful concept, percolation. So what percolation means in normal English, it means water dripping outside of a container. But in programming term, we understand it as error or exception dripping out of a program. So in case of OPM model, let's consider this box, the right-hand side, which is present in ORD search activation group. So obviously OPM model will not have this activation group name. OPM model runs in default activation group. So if some error comes, let's say in fetch order detail, this blue color box. Some exception happens in this program, and we are not handling the exception using PSSR subroutine or any other exception handling method, then it will throw a hard error on the screen. It will throw an exception message on the screen. This happens in OPM. But in ILE, what happens if some error comes here and it is not handled, it will not right away throw the hard error on the screen. It will go to the previous calling program. For example, in this case, search previous order. And if it is not handled in search previous order, it will go back again to the previous program until it reaches the control boundary. In this case, search previous order is the control boundary. So I think we all know what control boundary is. Control boundary is nothing but the entry point of activation group. So in this case, as we can see, search previous order is the entry point. It is the control boundary. So control comes here, and if it is not handled in search previous order, then in that case only it will throw the error on the screen. But if some handling is happening here for that error in this program, then we won't see any hard error on the screen. Only this program will be terminated abnormally, fetch order detail. So this is what percolation is. Now talking about handling overwrites and opens. If we want to limit the scope of overdbf and open query file in activation group, we can simply provide these parameters and provide these values in overscope parameter. So for activation group level scoping, the override applies to all program objects running in the activation group, and the override remains in effect until the activation group ends or the override is explicitly deleted. This is how we handle overrides. And talking about the performance. So activation group, as we all know, basically is of 3 types. Actually, it is of 4 types, but mainly we use in our day-to-day programming 3 types of activation groups: star caller or asterisk caller, asterisk new, and named activation group. Asterisk caller means the program will be called in the activation group of the caller program or previous program. And activation group new means every time a program is called, it will create a new activation group. And activation group name or named activation group means it will use a customized name as the activation group for the called program. If we talk about the performance, when we talk about new activation group, so whenever a program with new activation group is being called, the system has to create a new activation group. That means it has to do some task or some job. It is taking up the space, it is taking up the subsystem. It takes time, little bit of time, but it takes time. So that's why performance gets reduced if we use only new activation group. And if we keep using caller activation group, the performance will obviously be increased because the system won't have to create new activation group every time. But this is not feasible because we can't use same activation group for all the programs. In that case, the actual purpose of activation group will not be satisfied. With name activation group, it will be quite similar to new activation group. If we have every time we create a new customized name for the activation group, so performance will obviously be reduced. But in case if we use the combination of named activation group and caller, then we can optimize our codes. Every time it doesn't need to create a new activation group because we can use caller whenever needed, and whenever it needs a new activation group, we can use named, customized named. So this is the optimized method of using activation group. Now coming out of activation group and talking about modules. So module is an object which can be compiled, but it cannot be run. It consists of several procedures. The only use for a module object is to bind it to create a program or service program. So a program or service program requires at least one module and can consist of many. When we talk about program, it needs at least one module because one module will be treated as PEP or program entry procedure. it will carry the main procedure, which will be used to execute the program. And apart from this, rest of the modules will have no main procedure, just sub procedures. So talking about the binding, how these modules can be bound together. For example, if you see the first picture here, let's assume they are programming codes written in CL and RPG and COBOL and C, and we can use these respective commands to turn them into module. And once we have module objects available, we can use CRT-PGM command and create a single executable entity. So once these are created, these module objects are no longer needed. Even if they are deleted, this program will still work. So this concept is called bind by copy. Here, this small picture refers bind by copy. Inside a program, we can have a module, which a single module will represent a mainline module or PEP, program entry procedure, and other modules can have rest of the procedures. And all these can be combined together to create a program. But on the contrary, in bind by reference, when we create a program, it consists of only mainline module, and it refers a service program. And this service program carries the rest of the modules and procedures. This we'll understand better in our demonstration in our C section. Now here I have specified the difference bind by copy and bind by reference we just talked about. Now, we're talking about the advantages and disadvantages of bind by copy and bind by reference. In bind by copy, we have a clear advantage that it will be having a faster execution because there is no overhead, there is no reference. Code is directly copied to the program. Module codes are directly copied to the program. But the disadvantages are if you have a simple piece of code in module and bind it in multiple programs using bind by copy, each program will have the copy of the code, and that will increase the program size. So obviously it will occupy more memory space. And number two, if you modify the module, then obviously the first step is you have to recompile the module, and you will determine what are those programs which use these modules, and you will recompile those programs as well. So this extra task will be saved in bind by reference. So main advantage of bind by reference is maintenance becomes easier. If you modify the module or service program, only update the module and service program. You don't need to update the program. But there is also a catch we'll discuss later. And first point is you can run the procedures in service program instead of copying them into your program. So this way, program size won't be increased. It won't occupy that much space. And the disadvantage here is there is a possibility of runtime error, signature violation, and later on we'll understand what signature violation is and how can we deal with it. So before that, let's talk about service programs. Although I think most of us are aware the basic concepts of service program, but let's go through the description here, what I have written. A service program are very much like regular program. It's an executable object on the system. It contains procedures that you can run, except number one, instead of one entry point, a service program has many entry points. Number two, calls to it can be made from other code, not from the command line. Number three, you cannot call it with call command. Instead, you call the procedures in it, the same way you would call any other sub procedure. And finally, calls to a service program or a bound module are much faster than dynamic calls. When we log in our IBMi server, then we'll see how service program works. There we'll have much better understanding. Building service program. Okay. Service programs are built from module objects, just like programs. The only difference is that you use create service program instead of create PGM. I'm going to skip this slide because we are anyways going to create service program in our demonstration. Coming to binding directories. So binding directories are like library list. It's like pockets. It contains the service programs and module objects. So when binding directories become crucial, so let's assume you are developing an application which consists of at least 40 or 50 modules. And now there comes an opportunity or a chance that you have to create another module and bind it with the service program. So if binding directory is not available, in that case, what you do, you have to list down all those 51 modules again while compiling the service program. But this extra overhead we can avoid if we use binding directories. We can just list down all those, we can just add all those module objects and procedure objects in binding directory. And when we compile the program or update the program, we can just refer that binding directory. We don't need to list down all those modules while creating the program. So that is the main feature of binding directory. This also we'll understand in our live demonstration. Talking about the signature. Signature ID is a special identification associated with a service program. It guarantees that the interfaces of the caller and the callee are compatible. When a program calls for a procedure through a service program, the system verifies if the signature IDs match. A signature violation error happens if they don't. You can understand it like level check error in a program. If the record format identifier of the PF doesn't match with the record format identifier attached to program, then level check error happens. Similarly, if signature of service program doesn't match with the signature associated with the service program inside the program, then signature violation happens. So how can we deal with signature violation error? There are two methods. Either we can rebind all the programs. If we modify something in our service program, we create or update the service program, and then we rebind all the programs again. So this will be an overhead. The another method is we can manage signature using binder language. You can manage service program signatures by creating binder language, which is used during program compilation. By doing this, you can manage the handling of signature IDs without having to recompile ever again. So this will understand in our demonstration. How can we manage signature using binder language? But I'll give you some idea how binder language looks like. It starts from this keyword strpgm exp, which means start program export, and it ends with this keyword end pgm exp. And in the parameter signature, we can mention our customized signatures. And in between, we can specify those procedures or modules which we want to export. So whatever modules we list here, only those modules will be exported if we compile our service program using binder language. So what is the logic behind it? When we list down procedures inside binder language, it will be referred using the serial number. So the procedure listed on the top will be considered as serial number 1. Similarly, other procedures will have incremented serial number 1, 2, 3, 4, 5, 6. So if we add a new procedure and we add that procedure somewhere in the middle, then the serial number will be distorted. And we might get error or unexpected result. So to handle this, we can maintain two binder languages, which can refer to previous signature and the current signature both. It will be easy to understand when we'll see the live demonstration of this. Okay. Now coming to demo of examples. So let's jump to the screen sharing on PIO Lab server. Now, first we'll talk about multi-language support of ILE. I hope my AS.NET screen is visible to all. No. Talking about the multi-language support, I have created a program order. This program is present in PILib. If we do DSP PGM on order, then we can see it consists of multiple modules: order entry, order search, item information, order process, and reset log. So all these modules are written in different programming languages. Let me show you. The first one is written in RPGLE. The second one is written in C, which is integrated with ILE. So that's why attribute is CLE. Third one is written in COBOL, integrated with ILE. Fourth one is written in RPGLE. And the last one is written in CLLE. So all these modules have been written in different programming languages. And even though they are written in different programming languages, they are combined together to deliver a single application. I'll show you the source code of these programs. Now, talking about the COBOL, first we'll see the PEP, order entry, which is RPGLE. As most of us are aware with RPGLE format, I think it will be easy to understand. Here, I'm just mentioning the prototype in the beginning of the program, declaring this file, order entry log. And I'm not using any business logic here in this program, and I'm just updating the log. Wherever this file is used, I'm just updating the log in this file that this process is called. For example, if it is used in order entry, I'm updating a text in this file, processing new order entry, and just appending it with the timestamp. Nothing, I'm not adding any business logic here. And once we write the first log, it will jump to the next procedure, which is order search. Then it will go to the next procedure, item information. Then it will go to the next procedure, order process. And finally, it will just open the log on the screen and will show the output. That's it. No business logic. So let's see the COBOL program first. Item information. I'm just using the standard ID division and file control. Inside file control, you can see the same file I'm using here, ORD ENT log, and referencing it with FS1, WSFS1. And I'm writing the log record, fetching item information to this file. That's it. Here also, you don't see any business logic, just a log. Inside the C program, a basic C program, using the same file, ORD entry log, and writing the text processing previous order search. Using SQL RPGLE, writing the fourth log, processing order to the system. And that's it, using the same file, ORD entry log. Now, and the another CL module, this is just to reset the clear the file in the beginning. Now let's call this program and let's see what the outcome is. Yes. So all these modules have been invoked and each one is able to write in the same file its own log. First one is coming from RPGLE, second one is coming from C, third one is coming from COBOL, and fourth one is coming from SQL RPGLE. So this is how multi-language support is provided by ILE. Also, this is how bind by copy works, as I have already shown you or in the program description of order. So this program consists of 5 modules which are bound to it directly. So this is how bind by copy works. Now talking about the resource sharing and bind by reference. Same modules we can reuse to create another program, which is ORD-ENT-PGM, and that program I have created using bind by reference. Now I'm showing you the program description of ORD-ENT-PGM. Here you can see it consists of one program entry procedure, order entry, just one module. And further, it is referencing a service program, order SRV. And if you open this service program consists of those modules: item information, order process, order search, and reset log, written in different languages. So we are reusing the same modules, sharing it with another program, and here we are using service program to refer these modules. So this is how bind by reference works. So once we call this program, I believe it should also deliver the same output. ORD, ANT, PGM. See, we are getting the same output using the same modules through service program. So bind by reference also achieves the same output. The only difference is in bind by reference, program doesn't occupy much space because we are referencing the modules at runtime using service program. Now, talking about the signature violation. As you have seen the signature already, let me show you again. In ORD ANT PGM, we have signature listed here for order serve. I'm using a customized signature, order serve underscore 1.00. Now, if I recompile it without this customized signature, or if I just change the signature and call the program again, then we'll get signature violation error. I'll show you. I've already written the compile command so that we won't be wasting our time in compiling. Not this one. Okay, this is for creating service program. And now let's create it with different signature. Sorry, let me come to edit mode. I'll just comment out this. Here in this create command, you can see I'm using the same list of modules and exporting all the procedures. And if I run this, just after compiling. Now let's see what is the signature of order SRV now. See, here the signature is changed. It is no more order SRV version 1.00. Okay. Now, if we call it, it should throw a signature violation error, but it won't because of another major concept of activation group. This service program we have just invoked and it is still active in the activation group. I'll show you. For checking the activation group, you can use option 18 and you can see yes, activation group PIO lab is still active. Let's reclaim this PIO lab. Now, if we call ORD ENT PGM, it should fail. See, error found on call command. If we take F1 and see the error in detail, we can see program violation error, program signature violation. The only reason why this came because signature of the program, signature of the service program doesn't match with the signature associated with the program. Now, how can we fix it? Let's see the scenario happens when you are adding one more module. And I have created one more module. OD underscore ASN. Let's see, we are adding this one more module in our service program. How can we manage it using binder language? So first of all, let me add this. Already this command is prepared. I'll just comment this out. This I'll show you. I'm apart from these modules, I'm adding one more module here, ORD underscore ASN. And here I'm using a binder language or orders version 01. Before running this, I'll show you the program, binder language. Just let's compile it. And so this was the previous binder language we have used for creating the service program order SRV. And we have customized signature mentioned here, order SRV 1.00. Now, when we added one more module in this service program, what we did, we created two versions of export list. One will be carrying signature order SRV 1.00 with previous level of program, and another one with current level will carry signature order SRV 1.10. So in this case, two versions of concurrent service program can be invoked by the program. First, let's compile. Yes, this is the one. Now I'll reclaim the activation group again. So it is not active. Now, if we see DSP PGM ORD int PGM, let's see the signature of the activation group here. It is 1.00 order SRV 1.00. And DSP SRV PGM order SRV. It has two signatures associated with it, order SRV 1.00 and order SRV 1.10. So if the program carries this signature, then also it will be able to run. And if the program carries this signature, then also it will be able to run. This is how a signature violation is handled in case if we change something in service program. Let's call it without any further delay. Or ORD int PGM. There is no runtime error anymore. Signature violation has been handled. Now talking about the binding directory, as we discussed earlier, I will just end it in a couple of minutes, end the session in a couple of minutes so that we can jump to Q&A section. How we can create the binding directory, I'll show you. We have simple list of commands for creating binding directory and adding entries to the binding directory using CRT BND dir. Let's say we are creating this binding directory, order BND, and we are listing down these entries in this binding directory using add BND dire command. These modules we already know, these already exist. So let's run it. They must be. Okay, sorry. The binding directory is already exist. So that's why this program got failed. Let me show you this binding directory now, since it already exists. See, so this, we had already added entries inside this binding directory to save time. Now, for creating the service program using binding directory, you can use this command. Or I'll show you create service program. Let's assume there is XYZ service program. You can just take F10, go down, and here you can specify the binding directory. Instead of listing all the modules here, you can just provide PEP and add rest of the modules inside the binding directory and add the binding directory here. So it can refer those modules directly. So since we don't have much time, I'm quitting from this demonstration and jumping back to the slides. Now, after demonstration, I just want to share the reference for the technical part. Whatever we learned in today's session uh, can be referred in the IBMi ebook. This is the link through which you can access, and this is the QR code using which you can refer the IBMi ebook. This is a great ebook where you can find all the details of every concept of IBMi in completely understandable manner. To the reference, we can jump to Q&A section. If you have any questions, I'll try to answer them all.
Okay, thank you, Sunny, for this session. And we have some open questions. So the first question is, if we hard code the signature, then is it mandatory to mention level in the bundle language?
Yes. So in this case, what can happen if you're hard coding the signature and you're using two levels, then there possibility that you're using two different customized signature for two different levels. So in that case, yes, it is mandatory to mention the level. But if you are using unified signature all over, I mean, for multiple levels, then you don't need to hard code the level if you are using the same signature.
Okay. The next is, sometimes after changing service program, the corresponding changes don't reflect in the main program right away. What can be the reason?
Yes, I think in the recent demonstration we saw, this happens when we are using the service program and that service program is being invoked in a particular activation group. And when we are going to change the something in that service program, that particular activation group is not released. So in that case, if we call the if we call the program which use the same activation group or same service program which use the same activation group, this will not, the changes will not be reflected. So the solution for it is before invoking the new service program or updated service program, just clear out the activation group or just sign off from your session and sign in again, and there won't be an issue.
Okay. The next is, can we check signature of the associated service program through program description?
Yes, let me show you. For example, let's check the signature of ORD PGM. I mean, this is a program, and let's see the signature of the service program associated with it. You take F11, if it's a customized signature, you can see here. This is just an example. there are chances that this service program might have acquired some more changes, and it might be existing with a new signature. In that case, signature violation happens, which we just discussed. Moving on to the next question.
Okay. Is there any way to remove obsolete modules from service programs?
Uh, the best way to deal with service program is like we can mention the we can specify the binder language, and if there are any obsolete module which we don't want to use, we don't want to export, we don't specify in the binder language the current version of the binder language. This is what I can think of. There may be other methods also to tackle this, but if you don't want to export, don't export from binder language.
Okay. Next is sometimes my OpenQuery file command does not work with my ILE program. What could be the possible reasons?
Yeah, it happens quite often because uh, most of the CL programs are written in OPM model. And as we know that OPM programs generally run in a default activation group. And the program which it calls subsequently, there are high chances that they are running in ILE model, and they might be using a different activation group. The only reason is they have two different activation groups of execution. We can tackle the situation by specifying the scoping in the OpenQuery file command. If you specify scoping as a status job, then that override will exist throughout the job, and this situation will not happen.
Okay. We have few more, so we'll try to answer them. What exactly are the resources when talking of activation group?
When we talk about activation group, resources mean the ODP, Open Data Path, when we use a file. For example, in the previous question, someone asked if what happens if OpenQuery file doesn't work. So OpenQuery file is mainly used for creating the ODP, and that ODP works as a resource when we talk about activation group, or the local variables which of the programs which are part of that activation group, or the file variables which are part of activation group. These are treated as resources. So when we clear the activation group, when we take out the trash, we free up the space for all these variables, free up the space for scoping. So this is how activation group works.
Okay, we'll just answer one more. We have a couple of questions. So what happens if all the programs, driver programs and subprograms are executed with activation group star caller?
Okay, this is a good question. So every time when a job starts or interactive job starts, it starts with default activation group. So if all the programs are using activation group caller, then this means all the programs will be using default activation group, and they are high chances that they will be running as OPM instead of ILE.
Okay. So, okay, as we are on time now, please send us your queries to us and we'll respond on the same. And thank you all for actively participating in this session. Thank you, everyone. Have a nice day.
Thank you so much, everyone.